Get this. Adults with financial literacy skills have 82% more wealth than those who don't. From swimming lessons to piano classes, us parents invest in so many things to enrich our kids' lives. But are we investing in their future financial success? With Greenlight, you can teach your kids financial literacy skills like earning, saving, and investing. And this investment costs less than that after-school treat. Start prioritizing their financial education and future today with a risk-free trial at greenlight.com/get-started. That's GREENLIGHT.com/get-started.
I can't believe you built us a spaceship.
What can I say? I've got a guy.
Yeah, I'm so excited.
I don't know.
Oh, come on, Heath. I know Eli's before-show shenanigans have gone wrong in the past.
Like every time.
But you got to admit, sending us on a 3-year mission to Mars to celebrate Cecil's essay on exoplanets and stars is pretty cool.
Nothing one best friend wouldn't do for another, am I right?
Still no.
Really? I built you a spaceship, and the answer's still no.
So about that, I mean, don't get me wrong. I know you have a guy for everything in this weird pre-show universe, but how did you afford this?
From the ground up, Heath. From the ground up. For example, do you know that most spaceships spend millions of dollars just on waste collection systems? It's like, y'all, it's space. I don't think we need to worry about littering. You know what I'm saying?
Eli, waste collection systems are code for bathrooms on spaceships.
Oh. I see.
This is what I'm talking about. Okay, so we should designate a corner, I guess.
We're weightless, Heath, on a 3-year trip. Everywhere is that corner.
Yeah, it's going to be the corner.
You still excited, Cecil?
Nope.
And welcome to Citation Needed, the podcast where we choose a subject, read a single article about it on Wikipedia, and pretend we're experts, because this is the internet, and that's how it works now. I'm Eli Bosnick, and I'll be talking about Uranus tonight, but I'll need some astronauts to help me. First up, two guys who are happy to explain to starving children in Africa that without space exploration, we wouldn't have Velcro, Cecil and Noah.
Look, you can't sing We Are the World without that sweet orbital shot at the climax of the
Thank
song.
you.
Impossible.
and to be clear, there'd be starving kids in Africa regardless. It's just a matter of who gets to be the ones they're most jealous of.
Good point. Good point. And also joining us tonight, the star of our little galaxy, Heath Enright.
Come on, you were doing astronauts. You had starfish. Do starfish. It's an ass.
Well done.
Showtime. Go ahead.
Before we begin tonight, I'd like to take a moment to thank our patrons. Patrons, you have the bravery, cunning, and courage to go where statistically almost nobody goes before, the frontier of giving us money. And if you'd like to give us money, be sure to stick around to the end of the show. And with that out of the way, tell us, Noah, what person, place, thing, concept, phenomenon, or event will we be talking about today?
Okay, so first of all, we're going to clarify that NASA had nothing to do with Velcro, and then we're going to move on to talking about stars, and in case 0.4% of all the universe's mass doesn't fill up a whole essay, exoplanets.
Wait, they didn't invent Velcro?
Not even Velcro. Not even Velcro. And Cecil.
What do they even do there? Whatever.
Thank you. And Cecil, you're kind of moving in on Noah's turf here. Couldn't find an article about jogging or something?
Look, Noah and I can threesome space. It's big enough to handle it. Come on, man.
All right then,
barely.
Cecil. Tell us a sad story from your childhood that you won't realize is sad till you say it out loud on our podcast.
Okay. I quit the show. You know, I've always had this massive soft spot for astronomy. You see, as a kid, I got my hands on this super cool book. Might have been a Time Life one. Can't quite remember. The thing was jam-packed with crazy facts about the cosmos, all the planets, stars, and all the wild things happening out there in space. I lose track of time, buried nose deep in that book, just soaking up everything about our solar system and beyond. And one part of that book that really grabbed me was all about Voyager. Some listeners may remember the episode I did on it in September of 2019, but that book wasn't just about Voyager. Oh, no. It was a treasure trove of space mysteries and wonders. So today, let's dive back into the universe and rekindle some of that childlike wonder as we explore some of the more incredible outer space phenomenon that fascinated me all those years ago, those long, long years ago.
Okay. That's a beautiful sentiment, Cecil. But like, are bad people going to die of stupid? I don't understand. This doesn't fit. Who versus? Who are we versus?
Thank you.
This?
Yes. I used up Uranus in the intro, Cecil. We're out of funny space.
Okay. So, all right. So, I'm sorry. I'm still coming to grips with the fact that Eli saw Cecil's story about loving a book as a kid, and he thought, well, that's sad.
Come on.
What a sad story. That
We
he liked
all
a
know
book.
what it was,
one
a
of those
library
books
book.
from like ShopRite that I had
Yes,
too, that tells
exactly.
like the encyclopedia for like 50 cents.
Flimsy
Cecil, you had that,
paper.
right?
I got it at a garage sale.
You got it.
Well, now it's sad, Cecil. Damn it. I was trying to
I got a
defend you.
used version
Awesome.
of it. Yeah.
Yeah,
The 50 cent version I had
absolutely.
was new, Cecil. I'm rich.
I got your version.
Yeah, you got it.
Yeah,
from
right.
All the pages are stuck together.
Okay. So let's start with stars, and not just any stars. Let's talk about the biggest stars we have discovered.
The Kardashians.
Okay, so stars can be the largest in two ways. First, in physical size, and secondly, in mass. So you may ask, what's the biggest star we've found when it comes to size? There's a few contenders in the ring, but the undisputed heavyweight champion that we're confident about is VY Canis Majoris. This is not only one of the most massive stars in the Milky Way galaxy, but it's also one of the most luminous. This star is about 1,420 times larger than our star here in our solar system. So if you plopped it in where Sol is, its outer edge would be past the orbit of Jupiter.
Sorry, are
And if
you saying soul for
Jesus
the sun right now?
For the sun, yeah. For this,
That's the name of the sun. Its name.
can you laugh
Dead
a
name
little
of the
more
sun.
mockingly, Heath? Is that possible for you to do that?
This is like saying Ibiza, but for astronomy.
Okay. All right. If you were on a spaceship
Proper name.
that could go the speed of light, it would take you 14.5 seconds to orbit the sun. But if you wanted to do the same thing at VY Canis Majoris, better load up that new audiobook because it could take you 6 hours.
Yeah, but the way I
Jesus.
drive, I'd still manage to back into it while trying to park somehow. Like, I don't know. I'd do it.
Sure.
Yeah, so like those like size comparison videos of the universe or whatever. This one shows up 6 stars after you've run out of ways of saying now you're just fucking. That's this one.
Now, fun fact, VY Canis Majoris is not just a heavyweight when it comes to size. It also shines with a luminosity that's 500,000 times that of our sun.
Soul,
With that,
you mean?
Our soul. Thank you, Heath.
Yeah.
You're listening. With that brightness comes at a cost, though. It's burning through its fuel at a much higher rate than our star, which is Sol. Thank you,
Sol.
Heath. I knew you were
Yep.
going to say it.
Mhm.
While our star,
God damn it, you were faster than me.
while our star will go out in about 5 billion years, and it's currently middle-aged, VY Canis Majoris only has a lifespan that is a fraction of that. Supergiants and hypergiants last a few million years, and when it does go out, it will produce one hell of an explosion, a supernova.
Okay, I feel like I'd be happier as a person if I knew the sun was going to explode in exactly 100 years. It's like the end of your senior year and like you already got into college. You know what I mean? Or like being a Republican in general. It just seems like easy and fun.
Sure.
Happy.
Supernova can occur in two ways, but this star will core collapse. The star reaches this massive size because it's burning fuel differently and at a higher rate than stars like our sun. At a certain point, the fuel in it can't sustain the growth of the star, and it will collapse back in on itself. At this point, it will explode. The explosion will rival the brightness of an entire galaxy and then will fade over a short time, weeks or months. The star will then either dissipate into a nebula, which is a large cloud of gas, or collapse into a white dwarf star or even a black hole. Pinning those for later. The explosion of a nova or a supernova creates a gamma ray burst.
Yeah, and somehow Noah's uploaded consciousness satellite will catch the only cloud in the universe and miss it. I don't know how, but
No, that's fine, Eli. I already got to see a supernova explosion from the inside on November 8th of 2016.
Gamma ray bursts are extremely energetic explosions that have been observed and are the brightest electromagnetic events known to occur in the universe. They can last from several milliseconds to several hours, though typically a gamma ray burst will last 20 to 40 seconds.
it's because they're so pretty.
Okay.
Gamma ray bursts can release more energy in 10 seconds than the sun will emit in its entire 10 billion year expected lifespan. The intense radiation of gamma ray bursts makes them observable across cosmological distances, with some of the farthest GRBs lying at distances corresponding to a time less than 1 billion years after the Big Bang.
Wow. Design of the universe, super intelligent. No notes. I have no notes.
Well, when it comes to mass, the heaviest star we have discovered, again with some surety, is BAT 99-98. Though its physical size is only about 37 times larger than our sun, its mass is an entirely different matter. The calculation suggests that BAT 99-98 possesses a mass that is a staggering 226 times that of our sun. This star also shines with 5 million solar luminosities, or it's 5 million times brighter than our star. But it isn't.
So,
But it isn't.
And two, Noah, and two.
But this isn't in the visual spectrum. It's only 141,000 times visually brighter than our star. The rest is in non-visible wavelengths.
Yeah, I grew up hearing that the heaviest things are the brightest, but it's nice to hear Cecil confirm it, you know?
We should also mention two other star qualities, brightness and temperature. Holding the title of brightest, we have Godzilla, a star 10 billion light years away from Earth. Godzilla outshines our sun by a factor of 134 to 255 million. Switching gears
Jesus.
to temperature, the hottest star that we have discovered is WR102. This star is about 210,000 Kelvin or 377,000 Fahrenheit.
a temperature previously only observed in pizza rolls.
In one little spot, and then there's a cold one right next to it.
And
It's
then
crazy.
there's a cold spot in that same fucking pizza roll. How the fuck is that even possible?
This star belongs to an exclusive club known as oxygen sequence stars, which are exceedingly hot and rare.
Like all members of exclusive clubs.
These stars represent one of the last stages in the life cycle of very massive stars, where they've exhausted most of their hydrogen and helium, leading to the unmasking of deeper layers rich in heavier elements like oxygen, which can be seen on the surface of the star.
Cool. Just like American capitalism, the geriatric star of economics. That's what's going on.
While WR102 holds the record for regular stars, when it comes to neutron stars, it doesn't even come close.
Oh, you weren't counting neutron stars. Because I was going to say, I didn't want to interrupt you, but I was like, what?
The hottest neutron star is PSR BO 943 plus 10. I don't know what that.
Plus?
I don't know if that,
And there's another one called Godzilla. That's the
I
weird
know,
part,
right? But
right?
I
Could
don't
it
know if
not be 0953? Why are they doing plus? Why do I have to do the math on that?
I don't know what the plus, if I should say the plus, or I don't know, whatever. Anyway, it comes to a temperature of 3.1 million degrees Kelvin. Neutron stars are not like ordinary stars. They're born from the dramatic collapse of supermassive stars and pack an unimaginable density.
Ah, the children of divorce of the sky.
Holy shit. Jesus.
Because it's their fault.
That joke. God.
Dramatic collapse.
These stars are so dense that a teaspoon of neutron star material would weigh Well, according to the internet, it's between 10 million and 10 billion tons. I couldn't find a good source that was specific. Wikipedia does say that 1 teaspoon of the stuff would weigh the same as 900 pyramids at Giza. So you do the math.
I'm just picturing the person with the teaspoon. Like,
Yeah.
Right. Yeah.
Somehow everyone in the kitchen is still in front of them. I said behind.
That 990 million ton margin of error seems excessive given that we can't actually check, right? Let's look at that. Where you were way off.
Another type of neutron star is a magnetar. This star has an incredibly powerful
Magnetic field.
magnetic. Thank you, Eli, for reading ahead. We already talked about how dense a neutron star is, but these also possess a strong gravitational pull, and their magnetic fields are the most powerful in the known universe. How strong? Well, you would have to increase our Earth's magnetic field by a quadrillion. That's a 1 followed by 15 zeros to equal it.
Jesus.
We have not discovered a lot of these. Out of all the neutron stars we've discovered, only a few dozen have been magnetars. And so it's theorized that perhaps there's a magnetar phase that the neutron star goes through, and it's relatively short-lived in astronomical terms, lasting only around 10,000 years.
Yeah, the part where I was attractive was the shortest part of my life, too.
Some neutron stars become pulsars. A pulsar is a rotating neutron star that emits a beam or beams of electromagnetic radiation.
Nothing from Eli there. So he didn't know that one. Okay. No, okay.
They do this at an interval in which they are spinning, similar to a lighthouse. As it spins, it periodically shines that light in one direction. So to our stationary observations, it appears as a pulse of radiation, which is how they got their name. These stars can spin extremely fast. There's another great name. PSR J1748-2446AD spins.
It could be minus, too.
Do
it might be a
letters
negative
now.
number, and you have to translate letters to numbers.
It could be. Actually,
It's
could be, because maybe they're talking about the coordinates. I don't know.
Come on.
Spins at a rate of 43,000 times per minute. That's 716 times a second.
Ooh, you know what? Maybe aliens exist. They're just constantly singing happy birthday to each other, and that's why we haven't heard from them.
Okay. So, because the star... Eli, of all your jokes that my inner science nerd isn't well actuallying in this episode, this is the one it's not well actuallying the hardest. I just want you to know.
It spins so hard. It's always their birthday.
There's a upper density to how dense a neutron star can be. This is called the Tolman-Oppenheimer-Volkoff mass upper limit. It signifies
that was a fight between those two people.
signifies the tipping point where gravity's pull becomes so overpoweringly intense due to the incredible density that not even light can escape. It's at that point the star transitions into a black hole, a singularity of space where matter is infinitely dense. Black holes form when a mass collapses under its own gravity, or when a particularly high energy collision takes place.
Right, yeah. Or when a plane touches down and every single person stands up into the aisle at the exact same fucking time, like an asshole.
When you get a supermassive black hole, sometimes you get a quasar.
Yeah, I get those. Preparation H actually really takes care of those. That, like, you just couple of days.
A quasar stands for a quasi-stellar object. Now, a supermassive black hole can range in size. It can be millions to tens of billions of solar masses. So this black hole will be at the center of a galaxy, and shit will just fall into it. As the space material falls in, it starts to form a large cloud of matter that surrounds the black hole called an accretion disk.
Right, it's like the line to get in, essentially.
That's a good way to put it. It's exactly like that. As matter in the accretion disk falls towards the black hole, energy is released in the form of electromagnetic radiation, which can be observed across the full electromagnetic spectrum. This makes quasars some of the most luminous, powerful, and energetic objects in the known universe, emitting up to 1,000 times the energy output of the entire Milky Way galaxy, which contains 200 to 400 billion stars. The intense luminosity of quasars originates from the disk of matter that's falling in, though, not from the black hole itself.
All right. Well, usually at this point in the planetarium show, I'm either jerking off asleep or both.
Jesus.
So while I excuse myself, we'll take a little break for some apropos of nothing.
and at this point, the gravity would become too intense for mass itself to hold its form.
Brilliant. We have to publish this.
Oh, I agree, yes.
Hey, guys.
Oh, hi, Dr. Oppenheimer.
Hi, Dr. Oppenheimer.
You guys can just call me Rob. You don't have to.
Sure,
Sam.
sure. Is there something we can help you with?
Yeah, I was just listening in my office. I couldn't help but overhear. You guys said something about publishing an idea?
Yeah, Tolman and I have been doing some research, and I believe we found the exact calculation for when a celestial body becomes a black hole.
Black holes. So cool. Hey, here's an idea. And this, again, just occurred to me just now. Why don't we call that principle you guys were just talking about the Tolman Oppenheimer Volkov principle?
I mean, no offense, Dr. Oppenheimer.
Rob.
It's Rob, sure. But why would we put your name on it?
I mean, I helped, right? I said black hole just now before Volkov did, right? I provided that.
No, you didn't. No.
You definitely didn't.
Okay. You guys like the coffee creamer this morning? Because I actually brought that in myself.
I think the office provides that, actually.
Well, we were out and I ran and got more before they got more, okay? So the point is that I helped with
Dr.
this.
Oppenheimer.
Rob, please.
Rob. Do you actually think you helped, or are you just hoping that if you put your name on enough science stuff, you won't be known for telling everyone you were the destroyer of worlds?
It's the second one.
Okay, Rob. Well, we'll put your name on it then.
You know everyone's going to care more about the death thing, though, right?
I do know that, yes. And we're back. When we left off, Cecil was fat-shaming neutrons or something. What was next in your smudgy, stolen little library book, Cecil?
So mean. Jesus Christ.
Ask him what a neutron is.
Next
It's
up,
illegal.
almost stars.
Shelley Duvall.
Eli Bosnick. Brown
How dare
dwarfs
you.
exist in a sort of celestial gray area between the largest planets and the smallest stars. They're also referred to as failed stars because although they form much like stars do, they don't.
They never learned to tap dance?
How dare
correct.
you both?
They don't. They don't have enough mass to sustain hydrogen fusion in their cores, which is the process that powers stars like our sun, Sol. Typically, brown dwarfs have masses between 13 and 80 times that of Jupiter. Below that range, they'd just be considered gas giant planets. Above it, they might be small stars. Because they can't sustain hydrogen fusion, brown dwarfs don't shine brightly like stars do. However, their gravitational energy converts into thermal energy over time, causing them to emit infrared radiation. And it's due to this radiation that brown dwarfs are often detected using infrared telescopes.
Oh, sure. But when I look at a brown dwarf through a telescope, I'm never allowed back at a different strokes convention.
Jesus Christ.
I'm going to get canceled just for laughing at that joke. Brown dwarfs have an incredibly long lifetimes. Unlike stars, they don't burn hydrogen, so they don't die in the usual sense. Instead, they simply cool and fade over time, gradually radiating away the heat left over from their formation.
We all have to dress as Mr. Drummond. I told you so many times.
Typical brown dwarf cools and dims slowly over billions of years, far longer than the current age of our universe, which is around 13.8 billion years. Even the oldest brown dwarfs in the universe, those formed shortly after the Big Bang, they are still in the cooling phase and have not yet fully died. In a sense, you could say that no brown dwarf has yet died.
Okay, we're all picturing Gimli in a jazz scooter at like Walmart, right?
The
Like, that's
most,
what you guys
the
picture.
most appropriate thing we're picturing, Heath. The most is you're the best of
You're
us.
not allowed back at the convention. Shh.
But so that's why I love the term failed star for those things, as though sustained hydrogen fusion was the goal. right? It seems like a pain in the ass for this whole sequence and everything. Brown dwarfs last forever and have no responsibilities. I feel like stars are failed brown dwarfs. Damn it.
Nobody wants to sustain fusion anymore. That's the problem.
Brown
with the
dwarfs are like the podcasters of the universe. It's perfect.
Yeah, absolutely. Yes. Thank you.
One interesting theoretical tidbit about brown dwarfs and massive exoplanets is the concept of iron rain. Brown dwarfs that are in a certain temperature range are believed to have conditions in their atmosphere that could lead to the formation of iron droplets, which could fall like rain. This is because the atmosphere of a brown dwarf can be very hot, like 2000 centigrade. At this temperature, rock could vaporize. The higher temperatures in the brown dwarf's atmosphere, iron is a gaseous form. But as the iron-laden gas rises and cools, the iron condenses into liquid droplets, much like water vapor condenses into droplets on Earth's atmosphere to form rain. These iron droplets could then fall back down into the hotter regions of the atmosphere, where they would evaporate back into gas, creating a kind of iron cycle analogous to the water cycle here on Earth.
Right, but you just know your hard-ass boomer boss still expects you to come to work in the sword rain, right? Just like,
there's plows out. You can make it. Swords to plowshares. Anyway, this, of course, isn't the only strange precipitation that can occur in the universe on planets hotter and colder than our own. There's another theory that large gas giants could support diamond rain, where carbon compresses in higher pressure rains and it rains down on the planet's core.
Or you could get that gun at the strip club.
Yes.
And that's awesome.
They like that
Everybody
one.
loves you then. You're not the worst at all.
Some planets could also have glass rain, where silicon melts on the surface and evaporates and then cools in the upper atmosphere, creating falling glass. In our own solar system, we have both methane rain on Titan that forms rivers and seas out of the liquid version of that gas. And we also have sulfuric acid rain on Venus, a planet so hot that the rain never touches the ground because it evaporates before it hits it.
Okay, I get that diamond rain would disrupt traffic or whatever, but I feel like it would be worth it just to see what kind of shit De Beers would come up with to try to convince you it was still worth paying him $100,000 a gram for that shit, though, right?
There are also planets that don't rotate around a star. They just wander through the universe untethered. These are called rogue planets. How these planets end up on their own is a matter of ongoing scientific study. One theory suggests that they may have been ejected from their original planetary system due to gravitational interactions with other bodies, such as passing planets or passing stars.
Okay, I'm picturing that meme with the guy looking back at the woman who just passed his girlfriend's name. She's pissed, but they're all planets.
Another theory proposes that rogue planets may form directly from collapsing cloud of gas and dust, much like stars, but without enough mass to ignite fusion and become a star.
yes, and yet another theory suggests that a Sumerian four-eyed god got in a fight with his grandma. So, you decide.
That one's actually encompassed in the first theory, Eli. Your cosmology is subpar this week. I'll be honest with you.
You are.
Rogue planets are difficult to detect because without a star's light to illuminate them, they're very, very dark. However, they can be found indirectly through a process known as gravitational microlensing. This happens when a rogue planet passes between a star and an observer, bending that star's light and causing it to momentarily brighten. While some planets head off into the universe on their own, leaving their star behind, some exoplanets like HAT-P-7b neber really venture that far away.
So lazy.
Their planet is a large gas giant.
P-7b.
Are you looking at your apartment number right now? No.
I'm in 7b. Fuck.
This planet is a large gas giant that is very, very close to its star. And because of its proximity to the star, it has extremely high temperatures and a very tight circular orbit, which it completes every 2.2 Earth days. Astronomers have also found evidence of extreme weather patterns there. Most notably, researchers detected the brightest spot on the planet shifts its position, which could suggest a shifting storm system with winds of up to 5,400 kilometers per hour.
Okay, so the Earth could go rogue, theoretically? Like if the sun gets shitty, we could hitch a gravity pull from some other thing and like go rogue
Yeah.
as a planet.
Floridians are already used to the weather, so, you know.
All right, so I get that fucking hot Jupiters can't exactly harbor life, but I still can't help but picture Republican hat B78ns or whatever get it on Facebook going like, it was only 1,400 Kelvin today and the wind's barely top 5,000 kilometers. Tell me again about this global warming, am I right?
Now we've talked about too cold and too hot, but what about planets in our universe that are in the Goldilocks zone? Okay, first, what is the Goldilocks zone? This is also referred to as the habitable zone, meaning the region around the star where conditions could potentially allow liquid water to exist on the surface of a planet. This is one of the key factors that lead scientists to consider a planet potentially being habitable or one that could harbor alien life.
And what are the odds of that perfect zone of life existing inside of a universe that's only like 93 billion light years across? It's God. That is God. God is love. That's the only explanation.
One planet we found in this zone around another star is Kepler 452b.
Okay, so I can't do the ooh thing because I smoked for 30 years, Cecil, but I would absolutely ooh this one if I could.
I got you. Kepler. Cecil,
I'll do it again. Kepler 452b.
Hold on, 452b? Ooh,
There it is. Thank you. Thank you.
I don't like most of the other Keplers, but that one's fucking great.
God, honestly, I'm not even a fan of the 452s, but 452B,
But the B?
Mwah.
Yeah. Come on.
It's like Pappy Winkle. Winky Papple.
Boing.
This is an exoplanet that was discovered by NASA's Kepler Space Telescope in July of 2015. It has been referred to as Earth's cousin or Earth 2.0 due to some of its Earth-like qualities.
Great. Now that it's a cousin, Heath wants to fuck it.
Okay.
What?
This
Is that what? Did it evolve to I like what? I don't like I have to like keep track of all these things and like walk them back every time. I'm not into cousins. I think that's bad. Go ahead, Cecil.
Okay. Thank you for clarifying.
Ah.
This planet is estimated to be about 60% larger in diameter than the Earth. Given its size, it's likely to be a rocky planet. It completes an orbit around its star every 385 days, which is only slightly longer than Earth's year. Its sun is older, and Earth 2.0 has been in the habitable zone of its star for about 6 billion years, which is about 1.5 billion years longer than our planet.
Ooh, and it's way older. Heath, this just keeps getting better.
No, it's not. I don't. Regular amount
It's also way bigger.
difference.
Its radius is about 1.5 times that of Earth, and it has 5 times the mass. A 200-pound person would weigh a half a ton there. What's so great about this is that we've only sort of recently started our exoplanet search. With new tools and technology that are coming out, we're just going to accelerate the discovery of these planets for the years to come.
All right. And if you had to summarize what you've learned in one sentence, what would it be?
Time Life books really do open up a whole new world of adventure.
Indeed, they do. And are you ready for the quiz?
I am ready for my gold star.
All right, Cecil. Speaking of stars, which of the following is the best name for a porn star? Like a porn star or group of porn stars.
So good.
A, Skeetlejuice. B, Peter North Star, obviously. C, Anus Major. D, Two Girls, One Cup, Pernicus.
Nice.
Or E, Stepson.
You see, you're walking into these jokes with stepson. You're doing this to you.
I know that
You're
was
doing
on
this to
me.
you.
I
You're
should
doing
have
this
just
to
not,
you.
but not cousins.
No.
And I have a lady friend who's a little bit older than me by like 3 years. It's a reasonable amount. It's totally reasonable.
I'm going to go with Two Girls, One Cup Pernicus because I think it's amazing.
That is correct. Well done.
I just want to preserve in history that Heath acknowledged his relationship for the first time on air to disprove that he's
Get
into
out of
cousins.
it. I had to do it.
To
You
win an
forced me into
argument,
it
yeah.
with all this weird cousins and wrong ages. Yes, I am in love with a lady person. That's right.
I remember when I announced my engagement to Hannah. It's just like this. All
Will you
right.
marry me?
Cecil, which unfortunately named astrological phenomenon did you skip? A, Oops, Leonids, a stronger than expected meteor shower, which we would have made cum jokes about. B, assassin galaxies, which you'd have to cut from the show anyway, so why bother?
Yeah.
C, Oogle 2005 BLG, 395 pounds, because Noah might injure himself in an acrostic attempt. Or D, Sagittarius B2, a planet so rich in ethyl formate, it almost certainly smells like rum and tastes like raspberries.
I 100% was going to put Sagittarius B2 in because of that glass cloud in the nebula that smells like strawberries. So that's the one.
Wait, is that real?
Yeah.
Yeah.
It has,
Come on.
It has the same, you can't breathe in outer space. So you can't smell or taste.
Why is it not called Planet Strawberry Daiquiris?
It's not a planet. It's a nebula. It's got a,
You're
it's a
the
glass.
planet.
Sol, specifically.
All right. So, Cecil, if a neutron star that was feeling a little embarrassed after all the mass shaming that you did today wanted to look a little slimmer for the summer, what should it do? A, try neutron system. B, join nothing. Okay, thank you. B, join Exoplanet Fitness.
Nicely done.
C,
I like that one.
Thank you. Get into a constellation with a much bigger, denser bunch of stars. Or D, wait for a bunch of pedantic analogists to show up with their teaspoons and thimbles and solve this mystery once and for all.
God. Man, C is so good. It's so good. It's C.
Planetary mascot.
Oh, it is C. It is C. I thought I'd get you with the E secret answer one, but no.
All right. Well, Cecil got to talk about his favorite planets today, so he wins.
Well, I'm going to pick the person who did make fun of me. Noah, you win.
All right. Well, for Tom, Noah, Cecil, and Heath, I'm Eli Bosnick. Thank you for hanging out with us today. We'll be back next week, and by then, Noah will be an expert on something else. Between now and then, Cecil will be gently running his fingers along the spine of an old book, whispering, "Now the whole world knows about my friends." And if you'd like to help keep this show going, you can make a per-episode donation at patreon.com/citationpod, or leave us a 5-star review everywhere you can. And if you'd like to get in touch with us, check out past episodes, connect with us on social media, or check the show notes, be sure to check out citationpod.com.
And by increasing the density, you could trap light itself in such an environment.
Fascinating. Pass me that weird hammer.
Sure, yes, sure.
It's an Oppenhammer.
If you don't want to be known for it, you shouldn't have built the damn bomb, man.
Sound like my wife and Hamer.
Get this. Adults with financial literacy skills have 82% more wealth than those who don't. From swimming lessons to piano classes, us parents invest in so many things to enrich our kids' lives. But are we investing in their future financial success? With Greenlight, you can teach your kids financial literacy skills like earning, saving, and investing. And this investment costs less than that after-school treat. Start prioritizing their financial education and future today with a risk-free trial at greenlight.com/get-started. That's GREENLIGHT.com/get-started.